All right, thanks, Linear. So yeah, testing multi-app processes is complicated. What does that mean? It means that, let's say you have a very basic use case in your application. You would like to test some flow of your application's checkout process. In this particular case, what I have on the screen is a subset of things that a user would go through when adding an item to a cart, selecting the checkout process, shipping, payment, and completion. And this in itself seems to be multi-step. But what really happens when trying to validate something like this in a modern application is that you have all sorts of dependencies. Potentially the data for where the items is stored is in your SAP system. As a part of creating the account or updating the account, you're integrating with your marketing system, which is then potentially calling another system in order to actually upload some data from the application. You may use an S3 bucket, etc., etc. And all of this is required in order for your application to work. And all of this is powered by APIs of all different shapes and sizes, be they REST services, Kafka services, what have you. In order to do that simple validation of your use case, you need to make sure that all of these APIs are available, they are stable, they are consistent, and that they're serving up the right data. And this doesn't happen all the time. And so it can become quite challenging to test your business processes because of the dependencies that are limiting the testability of your environment. Additionally, we have identified there are some real impacts to these missing components in an environment. We found that 81% of our users attributed delays in development because they were waiting for an app or an API to be available before they could build their system. We found that testers were experiencing massive delays associated with starting a new testing cycle because they didn't have all of the necessary pieces together. And it makes sense when you say it out loud, but yeah, this is all attributed to missing components in an environment. A big one, though, is that even when you have those components in your environment, on average, an application would have something like 52 dependent API systems, but the testers would only have access to 10 of those, which means that if something were to break, you just simply couldn't fix it because you didn't have access to the system. And then the final piece here is that a lot of these APIs, especially when they're partner APIs, they have a cost associated with using them. And so even the simple act of testing in an environment like this can be prohibitive because of the costs associated with it. So what are some solutions that exist for this? This is where service virtualization and API testing come in and come together. The basic tenets around service virtualization or API simulation is that if you look at the diagram that we have on the right, in order to test that application, we have all those dependent systems. Service virtualization allows us to record the transactions that take place between our system under test and the backend dependencies and create mock representations of those. We can then swap those virtual services in the environments where we're having accessibility or behavior or cost challenges to allow us to test unconstrained. And this allows us to not only get the testing done and eliminate those delays, but start to put that testing into a continuous cycle because we'll be able to deploy the simulation at any point, even if the environment isn't complete yet. Now, one of the interesting things about this diagram is that, sure, we all say this is what an environment looks like, but we know in reality, this is what an environment looks like. Especially with the advent of microservices and containerized environments and ephemeral environments and CI-built environments, you bring a whole raft of new challenges associated with the environments themselves and the microservices contained within. And while not exactly the scope of this conversation, any technology that you choose to help solve this problem needs to take this complexity into account and needs to be able to communicate in event-driven architectures with choreographed services and event fire hoses so that you can not only simulate the easy stuff, but you can simulate those complex workflows that are actually the ones that are causing problems. So, what are some best practices that we can use for end-to-end testing in cloud applications where these types of problems are present? Well, it really starts with thinking about the API itself. So in everyday API interaction, you have two sides of the equation, typically. You'll have a consumer side, which is the authorization service, and then you'll have a producing side, which is the user service. The consumer consumes data from the producing API. In this case, the authorization service is saying, give me some details for this user. And then the service produces a response, and the authorization service consumes it. Now, if you're testing an application and you are building APIs, that's the thing that you are providing. You need to validate that those APIs are bulletproof and that they are providing the right functionality all the time to those particular consumers. That is where the API side of the equation comes in. It's actually your first line of defense. Let me validate all those APIs and make sure that they are behaving the way that I expect, and actually lock that in as an automated process so that I can know at a moment if something is going wrong with the system. Now, a really important concept here is contract testing. Now, here's my oversimplified explanation. So contract testing is actually built from the consumer's perspective. Every time you have an API that you are consuming, you should build a test that says, this is what I expect from you. And as long as you can make whatever changes you want to your API, as long as you don't break these things that I expect from you. And if you do, then you know exactly who you've broken, me. And now we can have a conversation around what changes I may need to make, or things that you may want to keep in place. And then from the producing side, you want to do the same thing. Any consumers that call you, you want to run their contracts every time you're thinking about making a change so that you can understand exactly the same thing. There's a test double concept that's in place here, because if you don't actually have access to that API at the time that you want to validate it, you'll run it against a test double just to make sure changes you've made in your application code are still working with the APIs according to your contracts. An important piece here is that these tests are written as code. They operate as code. You can run them as a part of your CI process. And it really does take a cultural process to have everybody in on this so that you can understand across the board if any of these pieces break down. But what if the testing focus is your application and you are calling other systems? You have dependencies that you need in order for that system to work. That's where the simulation piece can come in. And as I stated before, simulation allows you to create mock representations of the APIs across your environment so that you can swap them in if anything ever goes wrong. So how exactly does that work? Well, it all comes down to recording. Now, there are many ways to create virtual services. You can create them from service definitions. You can create them from request response pairs. You can simply mock them up from scratch if you're prototyping something. But at scale, recording is typically the way that we see this done. And it starts by establishing a man in the middle, a proxy, if you will. You then reconfigure your application to talk to this man in the middle. That then talks to the producing API. The producing API will then respond and provide the response back to the application as if the proxy wasn't there. But during all of that, the connection is listening. It's recording, and it is taking the recordings and looking for information on how to associate different requests to different responses so that you can create the virtual service from that. Then, if you ever have a situation where you're running your application and that real service is offline, you can use a failover trigger to swap right over to the simulated service, get the response, hand it back to your application as if nothing ever happened. And you can do this in a reactive way, as I'm showing here, or you can deploy the simulation ahead of time if you know the system is out. And as I said, there's many ways that this happens, but this is the easiest way to get there. So now what I'd like to do is show you a demonstration of how this would all work. Okay, so today I am going to walk through a demonstration of what API simulation and contract testing would look like. As I said, there's many solutions that are out there. Today I'm going to be using the Tricentis solution on a real-world example. So let's actually start with that. So what you see here is a demo application, and today I'm going to be taking the role of a tester who needs to validate some functionality in this application. But we've recently had some new features added to the product, which have added some changes to it. And I just kind of want to validate those. Essentially, how this application works is that a user can come in and they can get an insurance quote. They get the quote here on this final page. But in order for all of this to work, the user has to enter in a whole bunch of data into the application, and that's brought together to give them the final quote. All of this data comes to and from backend APIs. And spoiler alert, I've actually broken the application today, so we will see some functionality not work. So specifically, what's not going to work is when I come into this application and I need to enter in the insurance data, what I'm going to do is I'm going to enter in the insurance data for Jon Snow. And I'm going to hit enter. And something actually should have happened here, but you see that's not apparent to me. But it would be if I went and tried to hit next, it would say, no, you can't, this form is invalid, something went wrong. And what actually went wrong was that that backend API call to the CRM system is down. But you see, I wouldn't know that as a user just looking at the front end of the application. And so that is where we can start to use these concepts that we've been talking about. So here I am in Tosca Cloud. There's many solutions built in here, but one of them is the API simulation component. It's comprised of two pieces: the registry, where you host all of the different virtual services, contract tests, data sources that you need for your simulation, and then the agents that actually have that information. So if we were to go and look at the agents first, what I'm looking at here are all of the different agents that I have installed across the enterprise, be they on Windows machines, local developer desktops, enterprise machines, or even in Docker Cloud. This particular one is actually connected to that application. And if I were to go and look at the logs, I would actually start to receive some information from the back end. So here I see that actually just a couple of minutes ago, I got a failure. I'm just going to dock this on the right. And what this failure says is that it couldn't get person. It couldn't get Jon Snow. Well, why couldn't it get Jon Snow? Well, it says that that system is offline. Okay, well, that's giving me some good information. So from here, what I can do is I can actually go into my registry and say, well, I think I need to deploy a get person service into that environment. The service registry holds all of the different virtual services that you would use. I would probably search for criteria for the build or for the app or for the version or for the API. In this particular case, I've got it right here. And I know this is code, but don't worry. Essentially what this is saying is that I'm going to capture messages that come into this particular endpoint with some data, and then I'm going to spin back a response. Okay, so I think this is the service that I want. I'm going to go ahead and deploy that. Now what deploying means is that I am taking the copy of this service and I'm deploying it into the environment where I have the need. In this particular case, on that agent. And so that's now being transmitted over the wire onto that simulation agent. And I could go over there and look, but the proof is in the pudding here. Let's see if this use case actually works. So we'll go ahead and go through our flow again. We'll say automobile. And when that loads, we'll go into the insurance data. We'll type in our same use case here, Jon Snow. And now this time I'm actually getting data. I've essentially stubbed out the CRM service that's sitting behind the insurance data UI, and I'm now providing responses back. I can prove that this is coming from a virtual service by diving into my agent again and taking a look at that virtual service, in this particular case, this one. Now, I know that it is serving up a specific response here, but I have the ability to override this data. So why not? Let's just say I'll put in a really long string and maybe some malformed characters just to see what happens. I'll save that. I can dive back into my application. I'll reload this page. And I'll go through that same use case one more time by entering in Jon Snow tab. Okay. And so I know I'm getting the data from the virtual service. And actually, I know I'm just stubbing out dependencies in my environment, but I've actually kind of learned something here. this field isn't exactly doing the best job of letting the user know that the string length is exceeding the table parameters. And these are all sorts of things that you can do with simulation beyond just improving the testability of your environments. You can use them for early stage prototyping and supplying API data somewhere where you can't really control that behavior. But I've now solved the problem. I can proceed forward and I can do my use case. And now obviously I was controlling things manually from my UI, but in reality you would use our APIs or our plugins to do this as a part of CI. But in order for this to happen, a test had to fail. And I don't want a test to fail. I want to know if there's a problem ahead of time. And this is where we start going into the concepts of contract testing. So that endpoint was offline. I should have been able to know that that endpoint was offline before I even got started. And so virtual services can have a series of components. They can either be a virtual service, they can have a connection, which is the listening piece. Is it listening to a Kafka topic? Is it listening to HTTP? But they can also be runnable. And the runnable service is just the opposite of the virtual service. Instead of waiting for data to come in, it actually sends that data and then verifies the response that comes back. Contract testing is very similar to API testing. It's just that, as I said before, it's code. It lives in close fidelity with code sources. And if I were to open up my play page, I could load those different contract tests in. So here's one against the car service that lives inside of my application. Now imagine if, instead of doing what I did, if I actually started here and said, well, okay, I'm going to test all my APIs first. All right, this one looks good. I'm getting a response from the BMW service. I'm going to go ahead and call out to that CRM service now. And I'll go ahead and hit send here and wait for a response to come back. Oh yes, of course, my CRM service is offline. I knew that. And actually, if I had gotten this response, I would have known that ahead of time. So let me just test that my virtual CRM service, which literally just talks to a different endpoint here, is serving up the virtual response that I want. Ah, it is. This would have been great information for me to know as I was heading into my testing initiative, because I could have deployed the simulation before I ran the test case. And so bringing all those pieces together allows me to create a process where I can not only understand when my API endpoints are offline, I can understand where they are offline, what were the contributing factors, i.e. recent code changes, different build processes, environmental outages, and then once I've identified that, deploy simulation to plug the gaps. And so I hope this was a good practical example of how you would use these technologies in the real world. Okay. But where can we go with this? Now, we can actually start to understand a lot more of our environments because we are in the middle of these transactions and we are stubbing out different dependencies or running different API tests. By integrating with an observability tool, such as the ones you see on the right-hand side, or by aggregating the information together, we could start to understand the different sequence flows that take place in an environment and correlate those things together. And it wouldn't be too difficult to then take that information to convert it into a topology diagram. From this, you would then not only be able to understand where the different components are, but what components are comprised within the specific API calls and event flows that you are running from your front end or from your APIs. By having all of those different contract tests in place, they're essentially listening to the different connections. They're validating information as they go through the system. And you could actually bring those all together into one single event flow. And what that would allow you to do is then understand, okay, if these are all of the transactions that are taking place in my system, tell me something about this particular one. And then similar to your conversation history in Outlook, you'd be able to say, well, what was the consumer that made this call, and what was the producer's response? What is their connection to each other? And from that, you actually have your API test and your simulated service. Bring those together, and that is your contract test. And so I know that's a bit into the future, but that is a good way to kind of bring these different technologies together to create a nice process for testing those end-to-end flows in your cloud native environments.